Welcome to your second half of your trig equation lesson. Very short video lesson, just a couple of word problems to work through, give you guys some extra practice, and then you have the work period on Thursday to work on the rest of your homework. So example number 5. A Ferris wheel has a radius of 20 meters and takes 1.5 minutes to rotate around once. Determine an equation to represent the height above the ground a rider is over time if they start at the bottom seat, which is 1.8 meters above the ground. As always, let's draw a picture to start. Oops. So we got height with respect to time. And instead of me writing 1.5 minutes here, just because when you're dividing 1.5 into quarters, it doesn't work out terribly nice. You could keep it in minutes, but I'm going to change it to seconds. So 1.5 minutes really is 90 seconds. So we have 0 seconds, 90 seconds, halfway in between is 45, halfway in between that, 22.5, and halfway in between that would be 67.5. And again, if you wanted to keep this in minutes, you most certainly could. It says that the Ferris wheel is 1.8 meters above the ground. Now, if you wanted to, you could draw kind of like a Ferris wheel to mimic the motion. And that looks more like a football on a tee, but let's just go with it for now. So 1.8 meters above the ground. So if we kind of go across, that right there is 1.8 meters above the ground. It tells you that the radius is 20 meters. So from the bottom to the middle, that's 20 meters. So that means to my center would be 20 plus 1.8, 21.8 meters. And then to get my maximum height, add another 20, because if that radius is 20, that radius is 20. And if I add 20 more to that, I get 41.8. So if we kind of do this, 41.8. And then you kind of see how we have something circular, a Ferris wheel, but we're kind of making it kind of two-dimensional with a graph. This says that the rider boards at the bottom. So at time 0, he boards. Takes 90 seconds to complete one cycle, get back. Halfway, he would be at the top. And then at your kind of quarter points, he's at the equation of axis. And there's our motion. So we want to come up with an equation. For Brooke, let's pick cos. So we're going to start off with h of t equals, so height with respect to time. And my distance under the curve, my amplitude, it's always going to be your radius for these Ferris wheel type questions, but you can see here this has a distance of 20. And you could also do that by doing max minus min divided by 2. So 20. And instead of saying it's shifted to the right or left, I'm going to say that it's a cos graph that starts at the min. So I'm going to say this is a cos graph that starts at the min. That right there has a negative cos motion. So it's going to be negative 20 cos. My k value, got to figure that out. My period is 90, 2 pi over k. That means k equals 2 pi over 90. Reduce that, that equals pi over 45. We don't have any left or right movement, so we can just leave it like that. Pi over 45 times t. And then my c value, my equation of axis, is 21.8. So there's an equation that does model our motion. Again, there's an infinite number of solutions. Maybe you pick sine, maybe you pick positive cos. It doesn't matter. At the end of the day, we're all going to get the exact same graph out of it. How high up is the rider after 4 minutes? So this is something a little bit new compared to yesterday, or at least our first half. So the first thing, I made my scale in seconds, so let's convert this to seconds first. 4 times 60 equals 240 seconds. Now we're going to go to our equation. So going to our equation, h of 240 in this case, and if you kept your scale in minutes for the last question, you would sub in 4. I did seconds, so we're going to do seconds, and then negative 20 cos pi over 45 times 240 plus 21.8. Make sure when you are doing this that your calculator is in radians. So change your calculator right now to radian mode in case you haven't. And literally just enter it just like that. You should get 31.8, and it'd be meters. And we need a therefore statement. Therefore, the rider is up 31.8 meters off the ground. If you got a number lower than 1.8 or like a negative number, obviously you know you're wrong. You can't be under the ground. If you got a number bigger than our maximum, which was 41.8, again, you kind of have an idea. Maybe you made a mistake, because how could you be above the Ferris wheel unless you got flung off or something, which we're going to assume that that didn't happen. Our second example, in a harbor, the high tide is 10 meters at 2 p.m. Low tide is at 1.2 meters at 8 p.m. A certain boat can only pass through the harbor if there is at least 2 meters of water. Determine an equation that models this situation. Start with a graph. And we're going to start at, so we're going to say this is 2 p.m. Just kind of arbitrary. I'm placing it in the middle. It doesn't have to necessarily go in the middle, but we're going to say 2 p.m. We're at our high point, which is 10 meters. So there's a point right there. We know we're at our low point at 8 p.m. So somewhere over here, we are at our low point, which is 1.2. And this would be height with respect to time, and this would be time in hours. And that's all the information I give you. So you gotta do some deductive reasoning. Let's find our equation of axis halfway between those 2 points, which would be 5.6 meters. To get the rest of your points, you have to kind of realize that for any sine or cos, if you are given only the high and the low, for any sine or cos graph, high to low gives you half. So high to low always gives you half. So we know that right here between 2 p.m. and 8 p.m., that's going to give you half of your graph. So what's halfway between, again, you've got to realize things are in quarters. What's halfway between 2 p.m. and 8 p.m.? That would be 5 p.m. And we know we're going to be there. And then you just kind of work your way to the left. So basically it's in increments of 3. So 3 hours less than 2 p.m. would be 11 a.m. So we would be there again. And 3 hours less than that would be 8 a.m. And we would be back there again. So this one doesn't have like time is 0 and going to a certain spot. This is in hours. And we're going to have to adjust what we do based off of that scale. Now that makes sense, because if I told you that high to low is half of your graph, from 2 p.m. to 8 p.m. is 6 hours. So to get the other half would be 6 less. 6 less is 8 a.m. 8 a.m. to 8 p.m. is 12 hours. So we have our period of 12 hours. And it might be worth noting at this point that each one of these increments represents 3 hours. It's not kind of going from like 0 to 1 to 2. We're not going to enter time into our equation. We want to enter like number of hours into our equation. So this time let's pick a sine graph. My amplitude, my area under the curve, 4.4. So we have 4.4 sine. I need to come up with my k value. My period is 12 hours, equals 2 pi over k. K equals 2 pi over 12. K equals pi over 6. If we're picking sine, sine normally starts on the equation of axis. So we've moved to there as our start. So we've moved right. And again, you don't want to say you've moved right 11 hours because our starting point is 8 a.m., not midnight. So you got to think of these in increments of 3 hours. So I've only moved right 3 units or 3 hours. So t minus 3 and then plus 5.6. And there is a potential equation that models this situation. 6b, if the captain of the aforementioned boat wants to enter the harbor at 6:30 p.m., will it be safe? Provide algebraic evidence. So just like 5b, we're going to have to do some substitution into our equation. The first thing, remember, t is in time in hours. It's not we're not entering times into the equation. So we started at 8 a.m. That's where my graph starts. We need to figure out how many hours there are between 8 a.m. and 6:30 p.m. So how many hours are there between those two? With some very quick math, that right there equals 10.5 hours. Go to your equation. H of 10.5 equals 4.4 sine pi over 6, and we're putting 10.5 in. So 10.5 minus 3 and plus 5.6. Make sure your calculator is in radians. Enter that just like you see it, brackets and all. When you enter that into your calculator, you should get approximately.
Aaron Figueroa to the office, please. Aaron Figueroa to the office. Thank you.
Oh, Aaron. 2.5 meters. And in the last question, part A, it says there needs to be at least 2 meters of water. So to answer your question, is it safe? Yes, it's safe. There is at least 2 meters of water. In fact, there's 2.5. So therefore, it will be safe since 2.5 is greater than 2 meters. And that's it. A couple extra word problems, a couple extra things, just using our calculator, making sure it's in radians. And there you go. Have a good day on Thursday. Have a good long weekend. And I'll see everybody on Monday.